Hey everybody, um, welcome to week 3 of virtual learning. I noticed I got some new digs, got the office cleaned up enough I can use the office, so it feels good to have a workspace. Got out and hit some golf balls today, trying to make the best of some better weather. But I'm excited to be back with you when you get to see this, and I'm excited to support you as we start some new stuff. So we're going to start a unit right now on polynomials, big word. Uh, Polynomials really seriously means many numbers. And again, we're going to build this on things we already know. So it's going to be like a new thing, but it's built on old things. It'll actually be no super new knowledge except for some vocabulary. But for the nature of our time and how much we can get through, um, I'm going to be saying a lot of the vocabulary and I'm going to emphasize it, but you're going to be assessed on less things than that, right? Because we have to kind of pick and choose what we're going to go after this year and what's essential for next year. So I still want you to pay attention to the vocabulary and pick up on things I'm talking about. But on the assessment, we're going to be looking at more like the expression you pump out from multiplying. So today we're going to multiply a polynomial or a many-numbered thing by a monomial. So the prefix mono meaning one number or one term. So we have monomials, binomials, trinomials, polynomials. And we're also going to be looking at things called degrees a little bit. So really we're going to be really using the distributive property. And as we get into it, you'll see what I mean. Again, we're going to pull on things that we already know. I'm going to push you when you have questions. Make sure you're hitting up those office hours. This week, again, they're going to be Wednesday, 3:30 to 4:30. In a couple weeks, there's going to be a change, so keep an eye on those communications coming through your emails. Also, on these assessments, I'm giving you the opportunity to fix mistakes, so make sure you're using those opportunities. In order to give you your credit for a lesson, it's requiring a 60% to pass. So make sure you're hitting me with those questions. I'm here to support you. I've got your back. I'm really excited about this new stuff we're getting into, and I just hope you're all doing well, and I want you to know how much I really miss you. But reach out. Any questions at all, reach out. I got you. So let's get after it. So we're going to be looking by multiplying by a monomial. Not, oh, that little thing happens when I get into my writing thing. I think we're good. Not to be confused by the Monopoly guy's glasses. That is called a monocle. So don't confuse it with a monocle, all right? So let's get into this. We've got an expression. We know it's an expression because there's no equal sign, right? Look at right here. Nothing. So the way that we're going to simplify our expression is by utilizing the distributive property. So I can take this monomial, this third degree monomial out front, and I can distribute it to this binomial I have here in parentheses. And when I multiply, remember, nothing's magically attached. So this is going to kind of lean on some things we've been doing. So 4x cubed times 4n, I'm going to have 16x cubed n. So I have two factors of 4, that's 16. And then x cubed and n, I can't do anything with them because I don't know what x and n are. So I can't utilize those exponent properties we've been working on. Now I'm going to distribute my 4x cubed to my 7, and that gives me 28x cubed. Now, when I'm looking at my new expression here, I can combine like terms. So if I had the same variable, same exponent for a term, I could combine them. But this right here, this is missing that n. So if I had x cubed and x cubed, I could combine like terms. But right here, these aren't like terms. These terms are different because of this factor of n here. Again, I know some of this is going to be quick. Feel free to rewind it, watch it twice, whatever you need to do. Look at how Sal Khan on Khan Academy does it. You're not going to hurt my feelings. I know this is kind of just what we're working with. So let's look at this expression. It looks a little different. You might notice we have a variable here, again, and we're going to distribute our monomial to a binomial. This is called a binomial because there's two terms in there. So I'm going to distribute. 6 times 3 is 18, and then mn. I cannot do anything with the mn, nothing with the exponents. It's an m to the first power, n to the first power. Then I'm going to subtract by 6n squared. So right here, I have an n times an n, and an n times an n is n squared. So that's where some of those exponent properties, that's why we needed that unit first. That's going to come into our answers here. And remember, we're not changing values, we're just changing the way our expression looks, right? All right, let's look at our third example. We have right here, this is called a third degree trinomial, right up in here. Third degree trinomial. So the way I got that third degree is right here. The term with the highest sum of exponents on variables, which is a mouthful. Let me say that again. The term with the highest sum of exponents on variables determines the degree of your polynomial. So this is the trinomial. This right here, that's a monomial out front. This is a trinomial because of 1, 2, 3 terms. And the reason it is a third degree trinomial is because this term is a second degree. This term, x to the first, y to the first, that's also second degree. And this third term, y to the third, is a third degree. So we would name this as a monomial times a third degree trinomial. Not in standard form, but that's for a different day. So we're going to distribute our monomial out front 4 to all 3 terms inside of the parentheses. And that gives me 24x squared. That's my first distribution here. My second distribution, that's going to give me 16xy. And my third distribution here is going to give me negative 12y cubed. Now, none of these terms are like terms. So that's it. That is the simplified version of my monomial times a trinomial. All right, friends, we have one more here. It looks brutal, but it's not. Just stay with me. Nothing's magically attached. I'm just multiplying. It's kind of like a bunch of your mini exponent problems, but we have to kind of put it all together. So this is going to be a third degree monomial, so third degree, one term, times a second degree trinomial. So this term second degree, this term second degree, and this term second degree. That looks like a pea pod. Uh-oh, baby's knocking on the door. Hey, Luke, you're good, man. His mom's out there, don't worry. Okay, so second degree trinomial, there's 1, 2, 3 terms. Oh, man, he's really motivated to get in here. All right, so I'm going to distribute now. Negative 3 times negative 1, that gives me 3a cubed b squared. Nothing I can do with my exponents on the a and b. They're not the same variable. So next I have a negative 3 times a 2. That's going to give me negative 6. A cubed times the a is going to give me a to the 4th. Remember, when we multiply, we can add the exponents. There's a times a times a times a. And then b has nothing to multiply by. And then I have a negative 3 times negative 3 for a positive 9. A cubed times a squared is going to give me a to the 5th. And that is my simplified. Now, let's name this one. So this is a trinomial. It has 1, 2, 3 terms, so that's trinomial. And then 3 and 2 that's 5, 4 and 1, that's 5, and a to the 5th, that's 5. So it's 5th degree trinomial. If you want to, and you guys, pretty easy to do, and you can sound real smart. Be like, I took my third degree monomial, I multiplied it by my second degree trinomial, and listen, I ended up with a 5th degree trinomial. And even if someone doesn't know what you're talking about, you sound pretty smart. So, I just want to thank you for watching. I want to thank you for working so hard on all these. I want to thank you for being great students, and I so appreciate the time we had together in class, and I'm still appreciating this time too. It's just not the same. And remember, I've got you. I've got your back, all right? So make sure that you're reaching out whenever you need it, because I got you. I mean it. So see you Thursday or Wednesday if you come to those office hours. Be good.